Hi, welcome to everyone to the InnovaConnect. Um, Thank you, Laura and team Innova for hosting this conference. I'm happy to be here. My name is Gandhi. I'm founder and CEO of Moback, AR/VR technology company in Silicon Valley. What I will try to focus is help you understand how virtual reality, augmented reality is used in doing development and research focused on autonomous vehicle and robotics. So let me get started with the presentation. A brief about our company, as I said, started in 2012, focusing on mobile apps. But since 2015, we have been developing virtual reality and augmented reality applications focused on especially autonomous vehicles and robotics. We have been working for clients such as Google, Toyota, and other big clients. So what do we do with virtual reality and augmented reality? Our focus is building simulators, creating real life environments that allows first a user experience research and testing for autonomous vehicles. We can't put humans in a level 5 autonomous cars. So we build virtual reality simulators, simulating the real life environment, like a city or a block of a city and the car itself. And then we build physics and motions and sensors to simulate as if it's an autonomous vehicle. This allows researchers to let users sit in that kind of virtual reality simulators and do a lot of testing. The second area is we do user experience design and development for robotics. This allows us to simulate a robot's work environment, could be a warehouse, could be delivering a package, and it simulates robot physical movements in virtual reality. So these are the focus, and these are the areas that wanted to show you guys, specifically some use case that we have done with our customer. Okay? So the first one is project called Toyota Guardian. We had done for our client, Toyota Research Institute. And basically we built a virtual reality simulator, driving simulator, and first built a buck, a physical level of a car, which has a seat, steering wheel, pedals, all the haptics. And this allows us to simulate a physical environment where users could be brought in, they put in a headset and see the environment, but they also feel the sensors, the seat, the steering wheel, and the pedal. So they could be put in a kind of a real life driving simulator. And then once the simulator runs, it gives them a complete feeling as if they are driving a car within a city block. And once we simulate the autonomous features, such as detection of the road, vehicle, items on the street, the researchers can test a lot of experiences, such as someone coming in front of the car, the autonomous vehicle will suddenly stop. Where would the users look? What kind of indicators cars should have in an autonomous vehicle? So a lot of those user experience research could be done and testing could be done using this virtual reality simulator. So that's our focus in autonomous vehicles. Certainly will be open to answer a lot of questions if you guys have more on that. But it's a very innovative project. So we built physical simulator of a vehicle. It's a fully drivable virtual car with the experience of driving. And the virtual reality simulation of these self-driving features allows us or user experience researchers to test the autonomous vehicle features, design, development. And this Guardian project, Moback has created and has been displayed at Consumer Electronics Show by Toyota since 2017 in Las Vegas. So pretty interesting use of virtual reality and has been very successful project. The Toyota Guardian simulator has become or is currently the largest virtual reality simulator in the world that we are aware of. Okay. The next application that we have focused is using virtual reality for robotics, specifically for user experience design and development. What we mean by that is we develop a virtual reality environment such as a warehouse and a robotics itself, a robot itself simulating its physical movements. How would a robot arm move? This simulation and the movement needs to feel natural, because when a user puts in a virtual reality headset and feels the motion, it needs to be similar to what a robot motion will look like, not a human motion. And this we simulate within the virtual reality space. The feet, the hand, all motions needs to be simulated exactly, not like humans move different than a robot. And so once a human puts on the headset and then feels the robotic movements, it exactly is like the robot that would move into the warehouse, so the human can control them remotely sitting at a desktop, but the robot is moving in a warehouse. So we focus on the environment development, focus on the physics and the movement of the robot, and then specifically focus on the entire environment for remote operation. So it's pretty interesting. We call it XOVR, but it's focused on robotics and also kind of other areas where you have to bring in a physical object designed in 3D into a virtual reality environment. So that's a kind of a quick summary of the robots. This is the same XOVR project where instead of a robot, you can also import a 3D model of a car. And this will allow you to move around, make annotation, drawing around the car, sit inside the car and view the interior, exterior of the car, but also as a feature of collaboration. Another user could be coming into the same environment, and both could be viewing the same kind of a physical object, which is in virtual reality. So it's also a collaboration tool that we have built. So summary is we import robot models or car models to control and annotate on these models. We build real-time physics for interaction of the individual components, whether it's a robot or a car. And we also let collaboration with multiple users. So another interesting application of virtual reality that we have worked with. This is the final one, just wanted to drop in. We also use augmented reality for industrial application. One project that we had done for a defense contractor was a pre and post-flight inspection using an augmented reality application, specifically to check for a damage on an aircraft. Using a drone, you fly around and capture the video, which is streamed to the augmented reality application. And within an AR headset, an engineer can test the damage for an aircraft. This is probably multiple times efficient than walking around and physically looking at the aircraft and trying to figure out if there's any damage. So those are innovative applications. There are specific where you can derive a lot of efficiency using AR, VR, but these are the two areas that I wanted to present. Thank you, and looking forward to any other feedback or if you guys have any questions. Thank you.